Your 3D printer is only as good as your knowledge of how to use it. Regardless of how incredible your 3D printer is supposed to be, it will fail you if you don't take the time to learn the software side of things. Slicer settings can make all of the difference in terms of the quality of 3D prints you are getting off of your machines. So in this video, I'll be walking you through everything you need to know to go from failed prints to flawless ones fast. Let's start with what exactly a slicer is and what it does. Slicers are the software programs that take 3D models and turn them into instructions that your 3D printer can understand to then be able to print that object. It slices the model into horizontal layers and generates toolpaths for the printer to follow, including settings like speed, temperature, infill, supports, even filament color changes if you're multicolor printing. These sliced files are called G-codes. Now there are quite a few slicers available these days, both specifically for FDM printing as well as resin or SLA printing, but today we're just going to be focusing on FDM printing and the slicer setup in relation to those machines. A lot of 3D printer companies have elected to create their own slicer for their machines, but the majority these days are all based on Orca Slicer, which is based on Bamboo Studio, which was derived from Prusa Slicer, which was originally based on Slicer. But the good news is, because all of these programs are derived from the same source, they all work pretty similarly. So once you figure out how to use one of them, you can pretty much figure out how to use all of the others. For the most part though, if you have a Bamboo Lab printer, you're probably always going to want to stick to using Bamboo Studio, and then for any other type of machine, I personally prefer using Orca Slicer. It's literally compatible with more 3D printers than I've ever heard of. And from experience, it seems to do just as good of a job, if not better, than some of the native slicers that various 3D printer companies have decided to come out with. They're also basically clones of each other, so it's very easy for my brain to be able to flip between the two depending on what printer I'm wanting to use for a project. So those are the programs that I'm going to be using in this video to explain how everything works. But like I've mentioned, a lot of slicers these days are all very similar. All of the terms tend to be the same, so you'll probably be able to apply anything you learn in this video to another slicer if that's what you're wanting to use. And also just to mention, all of these slicer programs are free downloads. I know that's something that has been asked in comments of past videos, so just wanted to make sure I mentioned that here. I'm going to start with the basics and then we'll work our way up to some more advanced settings and techniques. The first thing we need to do is make sure we have the correct printer that corresponds with our actual machine selected. So this is Orca Slicer. I have an extensive list of machines, and you can also from here select and remove other printers. You can see Orca is compatible with an absolutely insane amount of 3D printers. Bamboo Studio is the same idea. As you can see at the top here, I have my Bamboo Lab A1 selected and then my list of other machines, and you can also add and remove printers in this same way. So if you end up getting another 3D printer down the line, this is how you will add that machine to the settings. Now, if you only have the one machine's profile on your slicer, then it will always default to that. If you have multiple different machines, then the first thing you're always going to want to do is make sure the right printer is selected. We're going to talk a bit more about this later, because when you're opening 3MF files, this is something you need to be checking. The other thing that I always personally do is turn on advanced mode. Again, this is located in the exact same spot between the two slicers, and what this does is it expands the visible settings for you to mess around with. Now, I know all of these settings are going to look intimidating, and the majority we're just going to be completely ignoring, but I do think it's beneficial to have advanced mode turned on just so you can visibly see everything, because there will always possibly be a setting that you're looking for and you can't find because it's just not part of the non-advanced mode. So I would rather you get used to seeing all of the settings and then learn which ones you're basically never going to be adjusting. And we're of course going to be going over what all of these different terms mean if you're not familiar with them yet. Because for the most part, there's only like 3 to 5 settings you really need to be worried about on any given 3D print. So to explain everything, I'm just going to add a basic cube to this build plate. The first thing we should probably talk about is how you even get a 3D model into your slicer, and honestly, my preferred method is literally just dragging it in. Creature here that I can just drag and drop. The drag and drop method always works well. You can go up to File and go like Import. Yeah, I'm gonna get rid of my little frog buddy. The other nice thing with these slicers, if you're not sure what a setting is, if you just hover your cursor over the icon, it will bring up a little explanation. So the very first icon at the top is add. So that is also how you can add a 3D model into your slicer. The next icon is add plate. So if you're working on a more advanced project that won't fit on a single build plate, you would click that and you can add a whole bunch of build plates or however many you need for that particular project. You've probably seen me use this a lot on droids because I like putting all of the droid parts in a single file so that I make sure I don't accidentally miss printing something. But we'll just get rid of all of those extra build plates for now. Next is the auto orientation command. The cube isn't going to be the best example for this, but if I do something like a cone, now I'm sure a lot of you realize that that probably doesn't look like the way you should be trying to print a cone, and you would be absolutely correct. So if you hit the auto orientation, you can see it selects what it determines would probably be your best chance of a successful 3D print, in this case putting the cone with the flat bottom on the build plate, which I would also agree that is probably your best chance and having this cone be successful. If you are working on a more complicated piece, the audio orientation might not give you the most desirable orientation for that particular piece, so understanding how to do it manually is also going to be important. But working across the top bar here, we have the arrange all objects. You can change how much spacing you want between each object and then the various parameters there, and it will auto arrange all of the parts across build plates from there. This can be useful if you've imported a bunch of models at once, just to get them easily spread out across the multiple build plates. To use these other commands on this top bar, you will need to select your 3D model. The next two things on this bar aren't currently applicable for this model, as well as the third thing. I would have all three of these being more advanced techniques, so we will be getting into them later on in the video. But from there you have your more basic commands. You have the move tool, so you can more precisely move the object. You don't necessarily have to use the move tool to be able to move this object around the build plate. The only one where you would want to be selecting the move tool is if you want to sink your object into the build plate. It's kind of the only way to do it. Next you have rotate, which will bring up 3 arrows that you can select from and then just use your mouse to rotate them. If you hover your cursor into more of the central area where you can see the lines, it will snap to those degree points. Next up is scale. Pretty self-explanatory. This is how you would change the size of the object you're looking at 3D printing. It gives you the option to adjust either the scale percentage or go in and pick particular measurements. So if I wanted this to be a 50mm cube, I could input that, and that ends up being 195.31% of the original size of this cube. You also have the ability to uncheck uniform scale if you want to make adjustments to each one of these directions. So if I wanted this cube to be a rectangle, I could just go in and adjust the size of one of the axes, and all of a sudden we have a rectangle now. Next setting we have is lay on face, which is where it will bring up a guide to show you the various faces of the object you're looking at printing, and from there you can select one and it will auto rotate to that face. So to actually show you this working, I'm going to change this cube to be at a 45-degree angle, and if we go up to lay on face, I can select this front side, and all of a sudden it is laying on that face. The majority of the rest of this upper bar are things that I would consider to be more advanced settings. We are going to be getting to those later on in the video. The one from this upper bar that I did just want to point out right now though is the measure tool. You can easily select 2 points on whatever object you're printing and it will digitally measure it for you. So let's say you're printing an object that has a hole in it and you want to know exactly how big that hole is. You can bring up the measure tool, select that circle, and it will tell you exactly how large that hole is. So it can be really handy to help you scale objects and know exactly the size of particular areas on your model. But now let's get into the actual print settings. For the most part, the only settings you're ever going to need to be messing around with are layer height, wall loops, infill, and supports. On the side panel here, the very first setting is literally layer height, and this is the height that the 3D printer will print this object at. When you're using a 0.4mm nozzle, which is what is typically standard across all 3D printers, the default tends to be 0.2mm layer height. And I would say for the majority of prints, you're probably just going to be leaving it at 0.2mm. If you are working on an object that has finer detail, you might want to lower this setting, and that way the printer will be printing that object in a higher resolution. And technically, if you're printing a larger object with very little detail and you want that print to go faster, you could increase this setting. But with 3D printers running so much faster these days, I pretty much always just use 0.2mm regardless of how large the object is. Something I did just want to mention, I'm not sure how much of a thing this really is anymore, but it always used to be that you would want your layer height divisible by whatever your nozzle diameter was. So for a 0.4mm nozzle, you'd be looking at 0.08, 0.12, 0.16, 0.2, 0.24, and so forth. Like I said, I'm not sure how much of a thing that really is anymore, but that used to be what you would always want to stick to for the best possible surface quality, just because the printers kind of liked it when you kept in those parameters. So just something to keep in mind. So once you've determined your layer height, the next thing we need to talk about is wall loops and infill. These are the settings that determine the strength of the 3D print. So I'm going to slice this cube right now so that I can show you the preview of this object. So this is what 2 wall loops and 15% grid infill look like. The orange line is the outer wall, the yellow line is the inner wall, and the red lines are the infill. So if we up the wall loops to, let's say, 5, and we can change the infill to, let's say, triangles, and reslice this plate, you can see the changes made there. All of a sudden the infill is now triangular shaped instead of cubes, and we have 3 more extra yellow lines representing the additional 3 walls that we added. So while technically both the wall loops and infill will affect the strength of the print, the walls will significantly affect the strength more than the infill will. And on the topic of infill, you can obviously change the type of infill that it generates, but you can also change the percentage that it's generating. So right now it is defaulted to 15%, but if we want this filled in even more, we can increase the percentage, slice this plate up again, and you can see that the red lines have significantly expanded and there's now a lot more of them. I'm not going to go super into detail on all of these different infill types. I know it always defaults to grid. I will absolutely never use grid infill. If I'm going for strength, I always use triangles. With grid infill, you have a lot of crossing going on the 3D print, so it is more likely to possibly knock the print over because you're crossing over those lines all of the time. It also could clog the nozzle on you or do other types of damage to the nozzle. So personally, I always pretty much stick to either triangles or gyroid. The amount of walls and infill that you're going to want to look at using is going to vary from project to project. If you're someone like me and prints a lot of props that you're going to be sanding later on, then I never go below 4 layers. And at that point, the infill doesn't matter as much. 15% tends to work really well for everything unless you are worried about the weight of a piece. And then the same idea, if you're worried about the strength of the piece, you can always increase the infill or the walls. But like I did mention, the walls increase the strength significantly more than the infill does. So if it is something that you really need to be strong, go for the walls before the infill and then maybe balance it out in between the two. Something like 7 walls and 25% infill. Also in the strength menu, you have the top and bottom shell settings, which is something you might want to look at modifying here and there, but for the most part, you're probably going to be wanting these to be the same for every print. The top and bottom shells are pretty much what the name suggests. They are the tops and bottom layers of your object. So this cube is currently sliced with 3 bottom shell layers. This is layer 1 of this cube. The blue lines are the very bottom surface. If we go up to layer 2, the purple lines are the second layer. Layer 3, purple lines again, the second bottom layer, and then at 4, that is where the infill starts printing. Same idea for the top. You can see we have 1, 2, 3, 4, and 5 top surface layers. When you're looking at 0.2mm layer heights, having 3 layers on the bottom and 5 on the top is pretty standard. You can see under both the top shell layers and bottom shell layers, there's something called top shell thickness and bottom shell thickness. And what this does is it ensures that the bottom or top thickness remains a particular measurement. This is particularly handy if you start using variable layer heights, it ensures that nothing is accidentally printed too thin. If I had the layer height set for 0.12 millimeters, that's going to be almost half of the top shell thickness if I was still printing that with only 5 layers than if it's printed at 0.2 millimeter layer heights. So putting a value into these areas can be helpful to make sure that you are always printing the top and bottom sections as thick as they should be. So because this is 0.2 millimeter layers, 3 bottom shells equal 0.6 millimeters thick, and then 5 top shell layers equals 1 millimeter thick. So having both of those parameters filled out with a particular thickness will just make sure that regardless of what other settings you might be changing, you're not accidentally going to be printing anything with too thin of a top or bottom shell layer. The next tab in this side menu is speed. Now honestly, for the most part, you're probably not going to ever be needing to modify this. The defaults for machines these days are very dialed in, and it's also one of those things that's pretty self-explanatory. It is the speed in which the machine is printing particular parts of the model. You can see the standard is it has the initial layer printing at 50 millimeters a second. If there's any infill on the first layer, it will print at 105 millimeters a second. The outer walls, 200 millimeters, inner walls, 300. The only time I ever mess with speed settings is if I'm printing in ABS or ASA. It's not even really a necessity, it's just what I personally prefer to do. And I basically take all of these different default values and pretty much have them. So the outer wall would be printed at 100 millimeters a second, inner wall 150. For the most part, you're probably not going to ever need to be dealing with speed unless there's an issue. But now let's talk about support. I'm gonna go back and rotate this cube a little bit so that we have a pretty distinct overhang here. So now that we have this cube at this angle, there is this bottom section here with pretty steep overhangs. That would probably not be a successful print without enabling support material, which we can very easily do by just checking this box. And now you can see the slicer has generated these green areas, which are these tree supports. And when you're just starting out, you really don't need to be too worried about the support material. If anything, when it auto-generates like this, it will overcompensate. So if anything, it's producing more support than you actually might need. And in the support settings, you have the type. So tree auto is what this type of support is called. You also have normal auto, which when I do this, I will change it to snug. And if we slice that, you can see what that looks like. The normal type of support is what it's called when it generates more of that square structure. If you are printing something more geometric like a cube or droid pieces, say, I typically would use the normal type of support just because I think it does a better job supporting some of these flat faces. And sometimes it will also end up using less material to support the objects because it just works a bit better when it's not an organic shape. Like tree supports are really great when it is more of an organic piece that you're looking at printing. It definitely does still work with more mechanical type droid parts. You know, it could be one of those things that's a bit more down to personal preference. I do prefer to flip it to the snug type. If you just do default and we slice that, you can see how it will like extend a little bit past the object, which again, sometimes it can be useful, but a lot of the time it's almost overkill for what you're printing. Like if I rotate this cube again a little bit, you will see how much of what the default type of support will almost over generate. You know, it's got this whole extra structure around the piece, and if I flip that to snug, it's now completely in line with the object. The threshold angle is the number that the slicer looks at using to figure out the auto generation for the support material. So you can see from the little pop-up here, it is support will be generated for overhangs whose slope angle is below this threshold. Now if we keep on going down here, the only other areas that I would say maybe look out for is the top Z distance and bottom Z distance. Normally you want to have this be the same as the layer height. The only time you would look at changing it is if you were using a different material for the support structures. And in that case, you don't need there to be any distance between the two objects because that support material will just presumably, you know, break away. The interface layers is also something you can take a look at. The higher you go for these layers, the easier it is for the support to be removed. So the default is at 2. If you find that the support structure is still a bit too difficult, you can always up that to 3. And the support interface interface is what this darker green area is. So it's basically this extra interface layer that goes between what is considered the support structure and directly below the printed part to support it better. All of the other settings on this list are things that you probably will never need to bother yourself with. The last setting that's really a necessity that you need to be taking account of is the filament settings and making sure that that matches up with the filament that you're planning on using. So because I'm in Bamboo Slicer currently, Bamboo has a lot of presets for their own filament as well as just the generic ones. All of these I've found are incredible. You really don't need to be messing with them that much. If you are using a Bamboo printer with Bamboo's own filament, you can very easily just select which filament from this list here that you're planning on using for your print. Additionally, if you select this little color button beside the type of filament, that is how you can change the filament color to like a preview in your slicer. If you're doing a single color print, this doesn't really matter unless you're using an AMS system that is going to try and match up a specific color within the AMS to use. But if you were wanting to mess with any filament settings, you just press those three little dots and then edit, and you can bring up all of the different parameters here and make adjustments. But like I said, it is something that I typically don't really mess around with anymore, which is awesome. The filament settings is one of the areas that I really love about the Bambu Lab system because they all just seem to be dialed in so well, not even just for their own filaments, but also everything else. And I've even gone in myself and referenced some of the other generic settings to then use in Orca Slicer for some other types of filament. So that's something that you can do as well for reference. A lot of filaments also will even have recommended print temperatures listed on them. So there's a lot of places that you can take a look if you're not entirely sure what sort of temperature settings you should be looking for. Something you've already seen me looking at a lot in this video is the printer preview. I use the print preview as reference all of the time, very similarly to how I've been using it throughout this video to figure out exactly how the settings are affecting the print job itself. And I have already gone over this a bit just naturally, but in the line type breakdown, you can see the guide of what each color means. And this is also where you can see an estimate for how much filament is going to be used in a couple of different metrics, as well as how long the print job is taking. In the color scheme, you can switch this to the summary will display it in the filament color and again give you the filament usage, the cost of the material, as well as the time for the print job. And then the slider bar on the side is how you can scroll to see how the printer is actually going to be printing this piece. The bottom slider will literally give you a preview of all of the specific moves the printer will make for that given layer. So a very useful tool to take a look at and also just to check in on how the print is going to end up being printed in the end. And if you maybe need to make some adjustments. One of the things you're probably going to frequently encounter is opening a 3MF file. I'm just gonna open the first one on my computer here, which is a chess set. 3MF files can be super handy, especially if you're starting out, because all of the settings are already input for you and should make for a successful print. If you are opening them on a computer though, the one thing that I sort of briefly mentioned before is it will default to a specific printer, and in this case you might need to change it. So in this chess set's case, it has defaulted to an X1 carbon, but let's say I wanted to print it on an H2D. So I'm going to just flip the print job and then all of the other settings should have transferred over from there. In the same way, you might want to be adjusting the filament that you're using. So both of these colors are supposed to be generic PLA, but maybe I want to be printing this in matte PLA. So I could make those adjustments there as well. Now let's get into some slightly more advanced techniques. First one is mirroring objects. If you're also someone who's very into printing droids, then you will know you need to end up mirroring the parts for either side of the droid. This is a pit droid foot. As it says down here, it is the right foot. There should also, yes, be an R listed here. So if I wanted to print both feet and also have one be the left foot, you can right click and clone the object, or you can literally just copy and paste it using the hotkeys that you're used to using on every other program on your computer. I'm just going to move this foot over here. And from there, you can also right click it, mirror, and then select an axis to mirror it on. So X-axis, and there we have a right foot and a left foot now. Another thing you might run into are pieces not fitting on your particular printer. So in this case, I've dragged this armor helmet and want to try and print it on an X1 carbon, and the top of the dome that's slightly darker is the area that is too tall for the printer to print. Now thankfully you can split pieces directly in the slicer now, and that is what that command at the top is, called cut. So if we select the cut, it will bring up this menu, and the two different colors are basically where the cut can be performed. So I'm going to drag this up and chop this upper section of the dome. I'm going to cut it below the upper horns just so that they're all together. Let's say about there, even though technically it could print a bit of those. You can also rotate it if you want. So, you could cut the helmet in half like that, but this is going to be a pretty simple, straightforward up and down cut. So when you have the object sliced where you want it, you can press perform cut and it will slice the object right there. We can add another plate and then drag the dome part onto that plate. And now this armor helmet is printable on this machine. Another slightly more advanced technique is things like domes, like the top of this armor helmet. You really probably don't need to be using support material on the inside of this dome. I'm going to disable support and we're going to take a look at it, because sometimes the dome will be too steep and it just really won't print. But again, it's one of those things, take a look at the slicing preview to figure out what is going to be possible or not, or a good idea or not. I would say this dome is a little on the edge. That blue ring is completely suspended. So yeah, you can see from the nozzle pathway, it is essentially printing in air. It still would most likely succeed without too much difficulty. The inside of the helmet wouldn't be very pretty, but if you were able to print this helmet in one piece, obviously not having the support material running up through the entire helmet saves you a lot of time and also filament. Speaking of domes, from the print preview, you can see the lines where it's generating the top surface layers. And domes are one of those things that can get pretty nasty looking, because the machine is having to come up with a way to print this curved surface in as efficient a way as possible. And a lot of the time it will end up with a pretty rough top surface. So if you want to improve upon that, we can use something called variable layer height. And if you click on that setting, it will bring up this menu where you can select just like an adaptive thing and it would automatically generate. An adaptive is the program coming up with like an auto generation of printing this piece in what it determines is the best way possible. When you scroll across this sidebar, it's telling you the layer height for each section. So the green sections are 0.08 millimeters, and then it hovers around there. The gray is where it's at about 0.2 millimeters, and then the red is where you go above the 0.2 millimeters. So I'm going to reset this because most of the time you're probably going to want to be doing this on your own. So again, going over to that sidebar, you can see as I run my cursor across it how it's highlighting certain sections on the model. So this top dome section is really the only area where we want to increase the layers to try and make it print smoother. So on the sidebar, I'm just going to click and drag and make it a little bit greener. From there, I do like to press the smooth command and it will smooth out the transition between where I've decided I want more layers to be and where it's going to go back to its typical 0.2 millimeter layer height. And you can go back and forth a few times, like if you really want that upper section to be dark green and be printing with a ton of layers, you just press smooth again. So that's what that piece is looking like now. And if we press slice plate, we can find out what this printer is going to do. So you can see there's been a ton more layers added in that section and it's looking a lot smoother, and when this gets printed it should also hopefully improve the look of that upper dome section. Less sanding for you later on. I'm not going to be covering any multicolor print settings in this video because I already did an entire deep dive dedicated video to that I will link below and also card here. So if you are specifically interested in the slicer settings for multicolor prints, then check that out. But in terms of some of these other more advanced settings that you might be needing to check out at some point, we have supports painting. That's the tool that you would be most likely looking at needing to use if you were going to stop the support material from generating on this upper dome of the helmet. There are some different types of tools that you could use. If we use the fill tool, and you right click and turn it red, that means that is the section where there will be no support material generated. And of course, in the opposite way, if you did want support material generated there, then you could left click that and it will turn blue, and then that is where all of the support would be going. Another group of settings that you might want to be taking a look at is in the others category, and that is the bed adhesion section. This is where we could add a brim to this piece. So for instance, I would most likely be printing this helmet in ABS, and I typically always like using a brim on those pieces because it stops any possible warping from happening. And a brim is a super easy thing to add to any more difficult prints. And what a brim is it adds extra lines of filament around whatever the object is that you're wanting to print to give it more surface area to adhere to the bed. You know, you have the brim width that you can change. So if we wanted an even wider brim, we can change that. And all of a sudden we now have a 10mm brim around the object. The brim object gap is the space between those brim layers and then the object itself. So if you find that the brim is almost too detached and not really doing the job that you are using it for, then you could decrease this to even 0, and then the brim will actually be attached to the object and you can remove it with a deburring tool or something similar later. Another slightly more advanced setting that can give you some really cool effects on your 3D prints is changing the top and bottom surface patterns. So this is again that chessboard that I used it as an example earlier, except this is the one that I was actually going to print. Now by default, the top and bottom surface patterns tend to be a monotonic line, but you can see from the drop-down menu how there's actually quite a few options here. And what this does is it changes the pattern in which the printer prints the top and bottom surface layers. So if we look at the monotonic line, it is the very typical back and forth that you're used to seeing on all 3D prints. But since this is technically the top of the chessboard, you might want it to look a little fancier. So I set mine to the Archimedean chords, and that creates this really cool spiral pattern. The octagram spiral is also really cool. It creates this like star pattern on the bottom. So you can customize into a lot of cool effects just by changing this one simple setting. You can equally change the top surfaces depending on the object that you're printing. So yeah, just by changing one simple setting, it can completely transform the object that you're printing. And that's going to be where I end this video. Hopefully this helped you get a better understanding of how to get the best prints out of your 3D printer. But that is everything. Thank you so much for watching, and I will see you in my next video.